Okay, hi everyone. Well, that was a bit of a failure. I was not able to figure out how to use HTTP caller to do this. I've never done it before. There are instructions on our community, so I got pretty close. I think my call just isn't well formed, and I'm not quite sure why, but I'd have to do a little more digging. Wasn't able to crack it in 20 minutes, unfortunately. Yeah, so I'll have to make a note to change that in the future. But the basic idea is there. You can use that data set attribute to do whatever you want with that data once you've written it out. So let's move on to our next section here in the course. Let me know if you had any questions that came up during that exercise. But we're going to continue to design for performance. So there's two performance sections in this course. In this one, we're going to look more at how should you basically set up your workspace, like what are best practices for building a workspace with performance in mind. Then we're also going to look at measuring performance, which is a bit of a tricky topic. So you'll see more about that in a little bit. And we will also look at parallel processing with custom transformers. I do want to give a little bit of a caveat performance sections of this course, which I usually end up giving, which is that I think the tricky thing about performance in FME is that my answer earlier about is it always faster to use a spatial filter on the feature reader? The answer is it depends. And that kind of applies to most performance questions in FME. Really, to get to the bottom of it, you basically have to benchmark, try a few approaches and see what's faster for your specific workspace. There are some general tips we'll provide you, which are valid in all cases. But in most cases, you are going to have to just try things out because it can just vary a lot based on how your workspace is configured. And additionally, even just something like measuring the performance of a workspace can be kind of difficult, particularly if you're working with web data. Where the bottleneck is can sometimes be hard to find. So those are just kind of caveats. This stuff can be a little tricky, but we do have some general tips and ideas to help you on the right path. And that's what we're going to go over in these two sections of the course. So let's start off by talking about performance methodology, some things you should just generally do and should get in the habit of doing, which will improve the performance of your workspace. One of the first ones is about filtering your input. I think when you're first learning FME, it kind of makes sense to do something like the example shown here. Add a reader feature type, read in all of the data, then use a tester to filter out just the features that you need. However, as we were talking about earlier, you can already see this is kind of an inefficient method. We read in 13,500 records. We actually only need 419 of those. So we wasted quite a bit of time reading these records. In general, with these examples, the time we're wasting, so to speak, it's going to be really minimal. FME can read 13,000 features very fast, a couple seconds, probably at max. We keep these examples small so that we can get through the training and we're not sitting here waiting. But you can imagine all of the stuff we're talking about is even more important when you're working with big data. So if you're reading in millions of records, this is going to be a lot more important. So some of the differences you'll notice in the exercises and examples are going to be really minuscule, but just think about applying those out to larger data sets. Now, in this case, what could we do differently instead of reading everything in, then using a tester? Some formats have a where clause in the reader feature type parameters, which you can use to filter the data basically as you're reading it. So instead of setting up a tester, read owner value or owner name begins with C, you can use a where clause, owner name like C with a %, an SQL where clause. You can use that to filter the data on read. And this is always going to be faster than reading everything in and then filtering it. So this is a good case of like, definitely do this if you can. Again, depends on the format, depends on if you're able to use SQL to get the exact filter that you need, but it's worth cutting down the amount of data you're reading using a where clause when you can. I think, am I going to talk about SQL transformers in this section? I will talk about them later, but I think we should maybe mention them here as well, just because this where clause is available in some formats. The other part of this, of course, is that if you can just use SQL to read your data, that's also probably a good idea. Rather than reading everything in and then filtering it, if you can use an SQL clause with some filtering in it, that will also likely be faster than FME. So if you have an SQL compatible format, use an SQL creator or SQL executor transformer to read the data in with an SQL statement. That will probably be faster than FME reading it. This is called letting the database do the work. These databases are designed to be performant in this area, so they'll probably beat FME in most cases. Let me make a note. I think we should probably just mention SQL transformers here as well. And then another big important thing here is don't read in extra data that you don't need, particularly with excess feature types. Here's an example. We're reading every feature type from a geodatabase. We actually only need 3. You can see based on the feature caches, FME will still read in unattached feature types. So if you don't need them, you should get rid of them. That's pretty straightforward. There are also some parameters which can sometimes be helpful to help your performance under the parameters features to read section of the navigator. So you can choose which feature types are read when the workspace runs. You can also limit the number of features that are read. So that section can be helpful, particularly for just testing, to sort of restrict the amount of data that's being read. Another huge performance killer in FME is carrying around extra attributes, particularly list attributes, on your features that you don't need. This, I think, is one big thing to look out for. I know when I build workspaces, it's very easy to sort of accumulate a bunch of attributes because you're probably, in my workspaces, I'm often joining data sets together or doing some kind of overlay and adding attributes. And what you should do is, that's fine. Obviously, you need to do those things, but you should only add the attributes you actually need. And you should get rid of them once you've used them. So if an attribute isn't going to be written out or used to do further filtering or analysis, you should remove it as soon as possible. Obviously, it takes a little bit of time to remove the attribute, but it's going to save you a lot more time to not have to carry that around with you through every other transformer for the rest of the workspace, particularly if you're just going to then discard it at the end. So here's an example using a point on area overlay, or if we're doing an attribute merge. You can see not only do we have a lot of attributes, we also are merging attributes from the points here, and we're doing it as a list. This addresses list, which contains basically all of the attributes for every address. These list attributes, because they can store multiple values in a single feature, are very big, or can get very big. And so that's another really important point is, get rid of the attributes you don't need, but really make sure you're not carrying around extra list attributes. Usually what will happen is you'll generate a list. You should use it in the next transformer and then get rid of it as soon as it's been used. And also just make sure when you're doing things like checking merge attributes, checking generate list, make sure you need to do that. And then for list, make sure you only add the attributes you need. It's easy to just say all attributes and you have them available, but if you're worried about performance, just choose the ones that you actually need. So here's an example where we're only adding the attribute we actually need. That can reduce the memory costs quite a lot. One topic that sort of fits in performance, it's a type of best practice that can be related to performance. It can also have benefits outside of performance, just for sort of development time, is error trapping. And so you can actually do quite a bit with this in FME. I remember the first time I was working on FME with a software developer at Safe, who works on our product, and I noticed that immediately their approach was a little bit different from mine. They built in error trapping, custom error messages, terminator transformers, etc., right into their workspace, which is something that I kind of understood from doing some programming, but hadn't really thought about doing it as in such a ubiquitous way when I was building a workspace. And that really changed the way I saw things, where I was like, yeah, why not? You should do this. This will help you detect edge cases. It'll tell you if there's an error exactly what happened, rather than being maybe an unhelpful error message. And so I'd encourage you to do this in your workspaces. There's quite a few ways you can do it. One would be things like using a tester to check to see if an attribute has a value. If you expect it to have a value, require it to, use a tester. If these attributes don't have values, you can do a few things with them. You could log them, you could ignore them, you could terminate the translation. You can kind of choose how strict you want to be. The logger transformer also lets you choose if you'd like to issue an information warning or error message. So you can kind of, again, tailor the severity based on what's happening in the workspace. The terminator transformer, when a feature goes into that, it stops the workspace and errors. So that's where, if you detect a definite problem, this is a workspace stopping emergency, you can use a terminator to do that. And there are some people out there who are, again, talking about software development, are applying software development testing practices to FME workspaces. So they're building basically test suites that will run their workspaces and check to make sure they're functioning as intended. We'll check for specific fail states and we'll report on those. There is, I'll put a link in the chat to this. One of our partners actually has a blog post where they talk about their product or their tool, RTest, which is basically a test suite framework for FME workspaces. Okay, so that's a good question. Can you check if a file wasn't written because you weren't allowed to overwrite it? That's a good question. When I've run into that normally, I've had my workspace error and stop because it didn't have permissions to write. I'm trying to think of when that wouldn't be the case. There must be something. Maybe is it feature writer doesn't give you an error or something? I know when I'm using a writer, for example, if I'm trying to write to Excel and I still have the Excel file open, FME isn't able to remove that lock, and so it fails. Now, how could you actually test for that if you didn't have a failure that stopped the workspace from writing? I'm trying to think. I mean, I guess in theory, it seems a bit onerous, but in theory, you could do a change detector. You could read the file you're writing to at the beginning of the workspace and then read it after writing with a feature writer, and then do a change detector on the data to see if it's changed, assuming you'll expect it to change every time the workspace runs. That would let you know if a change has happened. You can't use a tester for that, though, I don't think. There's no way to simply use a tester, I think, to check if the file was written. I'm trying to think of what else you could do. Yeah, that's kind of the only thing that occurs to me right now would be a change detector. There might be a lighter weight way to do it. If anyone else has any ideas, let me know. But I'm actually not aware of a case in which FME would say, I don't have access to this file, and it wouldn't stop the workspace with an error, which would tell you that it wasn't able to. That I guess it must exist since you say you've run into it, but I'm not aware of that case. And speaking of error trapping, one thing you might be curious about, a new feature in 24.2 is we added a rejected port to the Python caller. So you can now build that logic into your Python code if you're using Python caller, and take advantage of the rejected port for error trapping and handling kind of incorrect cases, which is helpful. That's been a requested feature for quite a while. Yeah, maybe some kind of CRC kind of checksum situation you could maybe use. Again, these are all kind of assuming the file would change, which is a little tricky. Like maybe if a workspace is running, maybe there's a chance it wouldn't change the file, but yeah, that would be an option. Okay, feature writer. Yeah, number of features written. That's a good point, Ryan. I wonder if you could use that maybe. Okay, yeah, that's another idea. Write to a different format and then compare. Yeah. So there's a few ideas there. I think there'd probably be ways to do it. So, okay, that's that lesson. Let me know if you had any more questions. Go ahead and work on the quiz for that, and we'll come back at 10:45.